Before European settlement of the Coweeta Basin, the land sustained the Cherokee Indian Nation of the southern Appalachian mountain region. Between the mid-1800s and 1900, settlers cultivated less than 200 acres of the basin. By the early 1900s, the United States was undergoing rapid industrialization, and logging companies harvested timber quickly to meet the demands of a growing nation, including the forests at Coweeta. During this period, debates ensued over the role logging played in regulating floods and water quality. Many believed that poor logging practices reduced the quality of the nation's water and increased flooding.
They were taking the best trees, and all of them that were good they took, basically. So what was remaining were crooked trees, defective trees, that type of thing.
To help answer these questions, the U.S. Forest Service established several experimental watershed studies across the nation, including the Coweeta Experimental Forest in 1934. In 1948, the site was renamed Coweeta Hydrologic Laboratory, the only Forest Service experimental forest to carry the laboratory title. From these early beginnings, the Coweeta Hydrologic Laboratory has become one of the premier long-term watershed research facilities in the world. The terrain at the Coweeta Basin is rugged, ranging in elevation from 2,250 feet to 5,250 feet. Precipitation is plentiful, averaging 70 inches at low elevations and 90 inches at high elevations. The large number of watersheds with well-defined boundaries and an abundance of perennial streams combined with the area's high rainfall, diverse forests, and different kinds of soils made the basin an ideal location for conducting hydrologic research. Once Coweeta was established as an experimental forest, workers began building the infrastructure needed to conduct hydrologic research. Most of the original buildings, roads, climatic stations, and stream measurement devices were constructed by the Civilian Conservation Corps. Almost immediately, researchers began measuring rainfall, stream flow, climate, and forest growth. By 1940, enough baseline measurements of rainfall runoff relationships were available to begin some land use experiments. Studies focused on practices common in the region at the time. These included converting hardwood forest to mountain farms, woodland grazing, exploitive logging, and clear-cutting entire watersheds. Findings from these pioneering studies altered and improved forest practices in the region and are still useful in addressing issues in many developing countries. The next period of Coweeta research involved experiments to determine the effects of different types of forest cutting and species conversions on water yield. Scientists performed a wide range of basic hydrologic studies, such as forest interception, water flow through soil, and the relationship between forest regrowth and stream flow. These early studies provided the foundation for transitioning to the next stage of research, in which Coweeta scientists used hydrology as a tool in ecosystem research. During this period, the philosophy of the research unit that quantity, timing, and quality of stream flow provide a measure of success or failure of land management practices remained basically the same. Coweeta researchers, however, initiated a new set of interdisciplinary studies designed to better understand both the ecological and the hydrologic processes occurring on the watershed, so that results could be more widely interpreted and applied. This new emphasis produced a research program that became a continuum of theory, experimentation, and application, using watersheds as landscape units of investigation. This ecosystem-based